Hi everyone, my name is Casey Zhang. I sit in the CloudNative Computing Foundation's Technical Oversight Committee. I'm also one of the leads of the newly formed CloudNative AI Working Group. Very happy to be here.
Hi, I'm Ricardo Aravina, and I'm one of the leads for the CloudNative Working Group in the CNCF, and I'm also a co-chair for the CNCF TAG runtime.
Hi, everyone. I'm Alalita Sharma, and I am a co-chair for the observability tag in the CNCF, as well as part of the GB, the governance board of the CNCF, and maintainer on the open telemetry project in the observability set of projects that the CNCF has. Super happy to be here today. And please be ready for your questions as we get ready to have a Q&A later. Over to you, Madhuri.
Hey everyone, I'm Madhuri. I'm founder of Ilotal. I've been in container ecosystem since 2015, worked on Flocker project. If you're old enough, you would know what Flocker project was. And before that, I worked at VMware on virtualization and spent some time on databases at Oracle. Really love cloud native ecosystem and the community, and excited to talk about all things AI and CNCF.
All right, so it so turns out that all my panelists are from Bay Area, so Bay Area is well represented here in Paris. So before we get started and dive deep into the discussion, I would like the audience to give some call-outs and what are they looking forward to from this discussion? Like any call-outs, shout-outs? You can like shout it out. Challenges for AI workloads. Anything else? LLMs. Batch supports are here. When I had asked this question last time, someone told me, or someone asked me if they can upgrade to Kubernetes control plane using LLMs. All right, okay. So be assured that all of these points are going to be covered in this discussion. So to start off, I'll start off with Kathy and diving right into it. Right, like with accessing AI infrastructure is kind of difficult right now. You need access to GPUs. So how do you see access to artificial intelligence infrastructure being democratized from an open source perspective?
Okay. So we all know that AI is evolving very fast, but accessibility to the hardware GPU is still a challenge. When we think about AI training or inference, we usually associate them with GPU. But actually, you can run AI inference on AI accelerated CPUs. So if you have challenge accessing GPU, you can try your AI inference applications on CPU with AI accelerators being turned on. Another area that can help, to simplify the accessing and the usage of GPU is to build an abstraction layer on top of, different hardware vendors' GPUs, and build a generic API layer that is, vendor neutral and also works across different GPU architecture and different computing engine, whether it's a GPU or CPU or FPGA or accelerators. As we know, right, I think it's not realistic to require an AI developer or AI scientist to know the ins and outs of every vendor's GPU architecture, because they're all different, right? And then if each vendor has its own APIs, then, as an end user, as an AI developer, you have to understand all these APIs. And once you develop your application on one set of API, it will be hard for you to port it to another architecture, another vendor's GPU. So to a newly formed foundation called UXL Foundation that was created recently to address this problem, to achieve this goal. So the foundation will build an abstraction layer and also a unified set of API based on one API open programming model, which can work across all the different architectures, GPU architectures, and different vendors. And so this will greatly simplify the end user's use of the lower level hardware. Also help promote accessibility to the GPU. So when you develop your app on on one vendor's hardware, you can easily migrate to another vendor's hardware, and and makes your life much easier.
I really like the call out for the hardware abstraction layer, which is vendor neutral, and also the unified API calls over there. So thanks for that. But taking the abstraction layer one step ahead, Ricardo, how do you see cloud native being more relevant to artificial intelligence, more specifically from, say, OCI artifacts or distributed training?
Yeah, so typically like LLMs that are very popular now are distributed using a GUF file format, but most of you were probably familiar with CloudNative and the OCI spec, so how containers are distributed. So I see maybe a synergy between that format and GUF and OCI working together, so you could distribute your models across different cloud native environments. So you can take advantage of all these registries like Harbor or other cloud native open source projects that help you distribute container images. So that's one way. I think also the way de facto way to running AI training and inference will be on cloud native open source, or ideally if you're talking about creating open source models. So I think that's another way that's going to happen going forward. And I think also of how you could use AI technology to improve cloud native environments and architectures. Generative AI is one thing, but predictive AI has been around for quite a while, and it's been used in several environments, for example, detecting anomaly detections on API latencies. So that's been around, and generative AI is going to even enhance that further.
Yeah, thanks for that. I like the call out for the use of predictive AI, the anomaly detection, and also parts of it which have been kind of sort of used in Kubernetes, mostly through audit logs and things like that. So yeah, thanks for that. But talking about AI applications even more, Alolita, how do you see profiling AI applications going forward?
I think, again, as we come upon the world of LLMs, which has, become the buzzword now, it's not that, work in this space, especially in building large-scale AI apps, has not been around. But I think, it's always a sweet moment when you see the cloud native infrastructure scale, if you will, converge with the applications that are being run for AI, using AI, right? And especially, as Raj just called out, it's like, so you're building AI applications. And how do you optimize them, right? And for optimization, again, you need observability and specifically understanding both not only the hardware, the infrastructure that you run on, but also the applications that you are running on it, right? And for that, again, going back to profiling, if you will, profiling is one way of kind of really understanding the behavior of software applications. Been done for a long time, all the way from the OS, from, many of you have worked on Linux, profiling itself. And, in the AI application space, the same applies. What is different today is really the advent of, large language models, for example. And what you are seeing now is that not only does it matter to have resource utilization understanding, which observability and profiling specifically gives you, but also, understanding performance of not only your software application, but also your models, your model inference, and your the actual, hardware that is used for AI applications, right? Including GPUs, not only CPUs, accelerated CPUs, but also GPUs and others. Profiling has many aspects that already, have been covered, but I think that, as we go forward in understanding some of the areas that can be improved upon, there are gaps in what you can observe today, right? And especially for AI applications. But that's something that, again, I think we'll dive forward.
Yeah, I can't wait for the cloud native goodness to be extended towards artificial intelligence, mostly from a profiling perspective. So yeah, that's like a very exciting space out there. But shifting focus to the end users now, Madhuri, what do the market trends look like? Like what works, what doesn't work for the users?
That's a really good question. So from an end user's point of view, our end user end user persona, which is a data scientist, needs a cloud native platform that not only meets their needs, which is don't make me bother about where the GPU is located, what's the price of GPU, what are these Kubernetes stack components, all of these things. Just give me a cloud native platform that is opinionated, that is recommended by the cloud native community, that also lets me, in addition to letting me run my AI ML applications, it also reduces the nag I have to face from the finance teams and the CISO. So the finance persona is the second stakeholder who is going to be concerned about, are you actually using the money that the company is paying you to use, right? Are you using exactly what you need, or are you spending more than what you're actually using? So the finance persona is the second stakeholder that the data scientist needs to be concerned about. And the third one is the CISO. So how are your data gravity requirements being satisfied? Is the platform that you're using going to be HIPAA compliant, etc.? And what doesn't work is the time for this platform is now. So we don't have the luxury that we had with the container orchestrators, where we figured out, okay, they had the Swarm, Mesos, and Nomad, and Kubernetes. Let's take 5 years to figure out where we have to converge on, right? So if the cloud native community doesn't come up with this cloud native platform recommendation within the next 6 months or so, the industry will go and build their own, and it'll be a bunch of bespoke stacks that will be running around that are not going to take advantage of all the community effort that we put into with the cloud native standard. So we need to get to this platform as soon as possible.
Yeah, actually, I understand the need for the reference architecture. And talking about reference architectures, that's one of the deliverables of the working group that's been formed in CNCF on artificial intelligence. So shifting gears and talking about the working group, this morning we got the white paper for cloud native and AI released by the working group. So huge shout out to all the folks involved in that. And Ricardo, being one of the co-founders of that working group, how is your experience been? What are your plans ahead? How does it look out?
Yeah, my experience has been great. A lot of folks interested in the space, joining a community effort to put, I don't know, like maybe 20 pages of cloud-native AI. We're talking about challenges, talking about the history of AI, the history of cloud-native, and how they're merging together now, especially with generative AI, and some of the opportunities ahead. So pretty excited about things to come, and some of the things that we're thinking about are, creating a reference architecture, or also a landscape. You might be familiar with cloud-native landscape, but we want to create one that is more targeted towards cloud-native AI. And we also want to make it easier for people to get started using things like Kubeflow, have maybe a constrained environment where people can just play around and understand the full life cycle of machine learning, which includes data prep, creating the models, storing the models in a model artifact, and then pulling those model artifacts and serving them in a microservice type of environment. So it's a lot of exciting things, and looking forward to the new things, and we hope that folks in the community get interested and join the working group. So,
yeah, actually, I think we welcome you to join that working group. We have bi-weekly meetings, and yeah, you can contribute, and together we can drive the cloud native and AI together.
Absolutely. I love the way the working group is shaping up. So if you're interested in where the action is happening, all things cloud native and AI, that's the working group to join. But taking things ahead and talking more about observability and the tag observability, how are your efforts shaping up, Alolita, and how does it look for tag observability to benefit AI?
Actually, very proud to say that, when we started the working group a few months back and we announced it at KubeCon in Chicago, the tag observability was one of the tags that actually, one of the co-sponsors of the working group. And so super excited with the work that the, AI working group has done. I think that, in general, and this is going back to one of the comments that Madhuri made, is that it's very, you're seeing a changing landscape, because one of the areas that is happening here is that obviously, we all live in the world and breathe in the world of Kubernetes and cloud native, right, today, because we all operate in the cloud native computing space. And many of our tool chains, as well as the projects that are related to that, the open source projects in the CNCF, are very foundationally, revolving around the universe of Kubernetes. Now, that also means that as the world of AI, and especially different types of black box models, different types of models that come in, different training pipelines, different types of workflows of data come in. There is a whole layer of assets, of components that are coming into this space, which not only does Kubernetes as a foundational layer need to handle and be able to have visibility into, but also the related spaces that we have in the landscape.cncf.io, for example, whether that's app delivery all the way to security or observability, also need to be able to have projects which are actually very aware of some of the new generation of applications coming into the space. And what that means is that in observability specifically, there's a lot of discussion happening on some of the open source projects, for example, as to what does that look like, right? Because you have interoperable open standards, for example. Do you have open specifications for what LLM metrics look like? What model behavior looks like? What do you define as normal thresholds, if you will? And those discussions need to evolve into different spaces, such as having the ability to have more white papers in specific areas, as well as semantic conventions defined, which are really standards for being able to interoperate across different data workloads in AI. applications models, as well as lower level observation components that exist today, like open telemetry, which is a collection pipeline mechanism, for example. And that, again, as Madhuri was saying, time is of essence, and that actually needs to accelerate. So I'm hoping that, with some of the discussions also going on in the tag observability, we can help accelerate that. And also, again, join more forces with the working group, the AI working group itself, to, maintain that momentum.
Absolutely. So if you are more interested in like defining the semantics for observing LLMs, then you know which tag to join.
Yes.
Kathy, you are one of the tech leads of the working group and also a member of the technical oversight committee for CNCF. Which innovative areas do you see, particularly in the open source realm, which are much more relevant to artificial intelligence, and where cloud native can contribute?
I think Cloud Native can contribute to 2 areas. One is performance. For example, when AI inference application sometimes do not need the whole GPU to run it. You may, for some AI inference application, you may just need a fractional GPU. So if we can, I think Cloud Native can develop a GPU partition or a GPU or virtual GPU aware scheduler, which will schedule your the AI inference workload or maybe some fine tuning onto a fractional GPU. That will help save the cost. And so that's one thing. Another is for example, you have for the distributed training is very popular today. So for distributed training, it usually involves communication between GPUs on the same server or across servers, right? And the communication link speed or cost for between intra-server communication speed and cost is much, the link speed is much faster than the inter-server communication link, right? If you zoom in on a GPU, you are going to see different links connecting the different components. So if we can build a GPU topology or hardware topology, and also the link cost aware scheduler, that will help schedule your AI service workload, service application onto a set of GPUs that renders the best performance, right? Because it takes the link cost between the different components or cross servers, right, or cross switches into consideration. Another area is, the Cloud Native can build, we can build a auto-scaler, which is guided by the actual real-time GPU or CPU or memory, utilization metrics. Based on that metrics, it can automatically scale out or scale in or scale up and scale down, and then to meet the current resource needs of that application AI service. So we all know that some AI application service has peaks, traffic peak and valley, right? So without that auto-scaling mechanism, you probably need to plan for the peak, right, to guarantee its service. But if with that mechanism, then you can save your resource cost, and then let that auto-scaler to automatically scale up and to scale down based on your real-time usage need.
Yeah, I really like those callouts. Thanks for that. We've heard from the leaders within CNCF on what lies in the future. So it's only fair to flip the side, get a pulse from the end user. So Madhuri, going ahead to you. If the end users were to ask 1 or 2 things to the cloud native community, what would that be?
A cloud-native platform that is that comes with a reference architecture that satisfies the three stakeholders: the data scientist persona, the finance persona, and the CISO persona.
That's great. I think a sustainable and a responsible future is what lies ahead of us. But moving forward, I'd like to go ahead and like keep one or two questions rolling, like which each of y'all can take a stab on. So, yeah, what areas would you recommend for people to keep in mind while building open source projects which are in the intersection of cloud native and AI?
Okay, I'll go first. I think the convergence of cloud native and AI will drive enterprise AI, edge AI, and PC AI, and leveraging technologies such as fractional GPU allocation and like the GPU utilization, telemetry guided auto scaling. So this will, when you develop solutions in that scenarios, I think you need to pay attention on resource sharing and isolation, because in those scenarios, the GPU resource is, or CPU, even AI accelerated CPU resource is limited. It's not like in public cloud. It's in your edge or in your in your AI PC.
Yeah, thanks for that. Ricardo, would you like to take a stab?
Yeah, I think one of the cloud native areas that is very popular now, or it's gaining a lot of steam, is WebAssembly. And I think you could actually use that technology to serve machine learning models. And one of the interesting areas is the edge, where you could actually create an inference service at the edge and make that maybe like an AI agent. So there are a lot of conversations about using AI agents. So basically, if you have an LLM, you could partition the responses or the workload of multiple LLMs. So at the edge, you will have one part of the compute happening in a smaller language model, I would say, and then send that over to a centralized, larger language model and do the rest of the processing there. So that's one of the architectures that a lot of folks are talking about creating, and I think Cloud Native can help in that area, and also WebAssembly, because it's very lightweight at the edge, and there are some other projects that have actually been using this pattern. An example is WASM Edge. It's a CNCF project. So yeah, take a look at that, and I think that's something that we can see more of in the future.
Taking machine learning to the edge, huh?
Yes, I mean, in fact, I think that given that, there is AI everywhere, I would say that the edge, as well as the core, is equally important from an infrastructure standpoint. And being able to observe, AI applications on the edge, as well as at the core, means that you can operate, AI applications both at the edge and the core. And it is, fundamentally right now that, as Ricardo just said, they can only run smaller models on the client, on the edge. And that's due to many reasons, if, hardware included. And as the world shifts, most folks want to, with concerns and rightfully guardrails for data privacy, security, and fair use, having those guarantees are best at the edge. And being able to guarantee that the infrastructure and observability and security and everything that goes with infrastructure is available end-to-end, that's the opportunity that we are, actually, I see as the next boundary where we need to address and work towards.
Absolutely. Madhuri?
Yeah, to add on to the edge conversation, providing cloud agnostic compute for your emerging workloads, your LLM, Gen AI workloads, cloud agnostic compute that honors your CISO's requirements and also is cost aware, that would be, I think, a very interesting area that there is a lot of opportunity for open source ecosystem at this intersection of cloud native and AI.
Yeah, totally.
And actually, I would say that, for that to happen, it's very important to have open standards and interoperability. And that's why, actually, cloud native open source matters.
Absolutely, right. It's all about fostering collaboration between the end users, researchers, maintainers, collaborators, keeping open source at the heart of it. With that, I would like to open the floor for questions. Anyone having questions on top of their minds? What would they like to hear in terms of like challenges in AI workloads or anything on those lines?
Hello, thank you for your words. I'm just wondering, how is the relationship with the hardware developers? Well, we know NVIDIA and the cloud native community. This is like my main yes or no idea of how this communication goes between developers of hardware and the cloud native community of AI. Yes.
So I think the question is how vendor developers and cloud native community communicates or collaborates. Is that right? Yeah.
Can take a stab at it. So this alludes to my earlier point about the need for going to market as soon as possible because of the demands of AI ML today. So the way we are looking at it is the hardware vendor plus the cloud provider providing the Kubernetes out-of-the-box solution, plus multi-cluster platform sitting on top. So have an opinionated stack that stitches these three layers together and go to market quickly. That enables us to go to market quickly. So the ecosystem is definitely working with hardware vendors. Happy to dig deeper into it in a follow-on.
Yeah, just a short add-on. I think we have a lot of folks from those vendors working in the CNCF community. So we have folks from Intel, NVIDIA. Not really sure if we have anybody from AMD, but we're trying to work with all the different vendors so we create those standards that can work across all of them, right? And then all of the end users can benefit from them.
In Cloud Native Computing Foundation, there is I would say it's called TAB. So if you are end users, yeah, you're welcome to join there. And then to, like for example, if you see some challenges, for you to use the cloud native infrastructure, right? You're really very welcome to, to voice your opinions there, and also to influence the cloud natives, technologies. And also, as we all mentioned, there's a cloud native AI working group. We really would like, the end users to join that working group. Whether you are AI developer or AI scientist or AI users, right? To give us your, feedback on the challenges and pain points, and then we can work with you together on solving those, right? We have quite some cloud native experts in that working group, but we would like to, close integration, with, the end users. Also, as I mentioned before, I think, down the road, a close integration from the upper orchestration layer with the hardware layer, there are several layers stacked, right? A closer integration will be very good for the larger community, right? So we provide a very simple end user interface on how to allocate the low layer GPU resource, or how to, dynamically adjust your resource boundary. Make your life easier, right? You don't need to understand the infrastructure. You don't need to understand the hardware. you can concentrate as an end user, as an AI developer, concentrate developing your AI models, right? And let that infrastructure layer automatically take care of all the either HA or resource scheduling, resource allocation, resource scaling, yeah, or like and any resilience, disaster recovery, all take care for you.
I think with that, we come to an end. We have a lot of other questions, but we'll take them in the hallway. This has been a great discussion. Thank you so much for joining the panel. Thank you, everyone, for attending, and have a great rest of the conference. Thank you.